All right, today we're diving into a really fundamental shift in how we build AI. We're talking about a design principle that could be the key to making sure that artificial intelligence stays a powerful tool that helps us and not, an accidental threat.
So let's just start with the question that should really be on everyone's mind as these systems get more and more powerful. What actually stops an AI from doing something it was never supposed to do? How do we build a system that we can actually trust deep down? Well, to answer that, we first have to really understand the problem. So let's take a look at what happens when a smart AI goes wrong, and it's usually because of this fundamental, almost invisible flaw that's hidden in the architecture of most systems out there today.
Okay, the core difference really boils down to this one design choice. The old way, the one you see on the left, is just inherently risky. You've got a single AI component that gets to think, decide, and act all by itself. It's like giving one person the battle plan, the launch codes, and the big red button all at once. The new way, on the right, builds a structural wall between these things. The parts of the AI that think are physically separate from the parts that act.
Now, this old combined design, it creates some pretty massive risks. First, you've got capability collapse. That just means a single breach in one component can cascade and just bring the whole system down. Then there's unbounded action velocity, which is a fancy way of saying the AI can act so ridiculously fast that a human could never step in to stop it. And maybe the most important one, safety in these systems relies on implicit trust. We're just hoping a line of code or policy setting holds up, instead of making it physically impossible for the AI to go off the rails.
Let's make this feel a little more real. Imagine your AI assistant is helping you sort through your email. It's reading a message that has a hidden command buried inside it. This is a classic attack called prompt injection. And this hidden command tells the AI to transfer money out of your bank account. In the old model, because the part of the AI that's thinking is the exact same part that can act, it could just do it instantly, and the money's gone. So how do we fix this? How do we plug this vulnerability at its very core? Well, the solution is actually beautiful in its simplicity. It's a golden rule. Separate the powers. And this one idea, it changes absolutely everything and makes the entire system safe by its very design.
The formal name for this whole concept is capability-partitioning, but all it really means is that you build an architecture that forces a strict separation between the thinkers and the doers. The components that have access to information, like reading your emails, have zero ability to take actions, like transferring money. And the components that can't take actions have no ability to think or decide on their own. No single part can do both. And this isn't just a suggestion or a policy, it is baked right into the system's DNA.
And this quote right here, it's the key to the whole thing. Reasoning is informational only, execution is action-capable only. It's such a simple distinction, but it's the rock-solid foundation for a truly secure system. Everything else is built on top of this one principle.
The best way to think about it is like a government with an ironclad separation of powers. You've got your strategists, and their only job is to write plans. Then you have bureaucrats whose only job is to review and approve those plans. And finally, you have operators who are only, and I mean only, allowed to execute an action after it's been fully vetted, stamped, and approved. No single person or group holds all the power.
So that's the big idea. But how does this separation of powers actually work in practice? Well, it all comes down to a mandatory 6-step safety check. Think of it like a one-way pipeline that makes sure every single action is carefully checked before it can ever touch the real world.
And this is it, the flow-controlled safety pipeline. So first, step 1, the system reads information from the outside world. Step 2, an AI model reasons about that data. Now here's the crucial part. Step 3, it doesn't act. It proposes a plan. It creates what's called an immutable task proposal. Then, in step 4, that proposal is automatically validated against every single safety rule. If it passes, it moves to step 5, authorization, which might even need a human to say, yep, this looks good. And only then, after all those checks have been cleared, can a completely separate, isolated service in step 6 execute the approved action.
So you might be wondering, okay, but are there any loopholes? Can a task somehow skip a step in this pipeline? The answer is a big, resounding 0. It's a rigid, one-way street. Authority only flows forward, from thinking to doing, with a mandatory check at every single gate. No backdoors, no shortcuts, period. So what does this all mean for the future? Well, it means we can finally start building real, foundational trust in our automated systems. Let's pull this all together and see why this architectural shift is such a massive game changer.
Let's just look at this before and after. With the old systems, safety relies on policies that, let's be honest, can be bypassed or misconfigured. Here, safety is enforced by the system's very architecture. Auditing old systems is a nightmare. Here, you get a perfect, unchangeable log of every single step. And as you add more and more agents, the old systems just get riskier and riskier, while this new model scales safely, without piling on that risk.
So when you build a system this way, you get some huge technical advantages. Unauthorized actions aren't just discouraged, they're prevented by design. You can safely mix and match dozens of AI services without creating new risks. The system is still super fast because a lot of these checks can happen in parallel. You get a perfect, verifiable audit trail for everything. And I love this last one. It treats all input, even your own voice, as fundamentally untrusted until it's been vetted by the pipeline.
And all of this leads to one final, really provocative thought. If we now have a way to build AI that is powerful, scalable, and fundamentally, verifiably safe just by the way it's built, is this the blueprint for how we should be building all AI from here on out?